Hello and welcome back to the Master Civil Engineering. In this video, you will learn that how to determine the correct bearings of lines of closed traverse using included angle method when local attraction is suspected while doing the compass surveying. Okay. I have been given a question which states that a compass traverse ABCDEA was run anti-clockwise and the following bearings were taken where local attraction was suspected. We have to calculate the local attraction and correct bearings using included angle method. Okay, you can see the lines of the traverse and their corresponding fore bearing and back bearings are given. Okay, we have to find the correct bearings. So first, what is a local attraction in compass surveying? Local attraction is actually a phenomena in which the direction of the compass magnetic needle deviates from the true magnetic north due to the presence of various magnetic objects in the vicinity. These magnetic objects can include electric wires, okay, steel rails, iron buildings, and other magnetic material. This presence of local attraction can be determined by checking the difference between the fore and the back bearing of the line. If the difference is deviating from 180 degree, it signifies that the local attraction is present in the field. Okay, and the concept which we use while finding the correct bearings using the included angle method is that if a particular station is affected by the local attraction, then bearing taken from that station will affect by the same amount. Hence the included angle calculated only from the readings taken on that station will remain unaffected. Okay, so if we take the readings from that station where local attraction is suspected and calculate the included angle, so it will remain unaffected. Okay, but you have to take both the measurements to find the included angle from that station. We will see it in the question. Okay, so first we have been given the fore and back bearing, so we will make a rough sketch of this closed traverse. You can see the line AB, it has a fore bearing of 150 degree and back bearing of 329 degree 45 minutes. Line BC, it has a fore bearing of 77 degree 30 minutes and back bearing of 256 degree. Line CD, it has a fore bearing of 41 degree 30 minutes and back bearing of 222 degrees 45 minutes. And line DE, it has a fore bearing of 314 degree 15 minutes and back bearing of 134 degree 45 minutes. And line EA, it has a fore bearing of 220 degree 15 minutes and back bearing of 40 degree 15 minutes. Okay, first calculate the included angles. Okay, so angle A, this angle A, it will be equal to fore bearing of line AB minus a back bearing of line EA. Okay, this will be the value of angle A, which is equal to 150 degree minus 40 degree 15 minutes, which is 109 degree 45 minutes. Similarly, angle B, this will be equal to 360 degree minus this back bearing of line AB plus this fore bearing of line BC, which is equal to 360 minus 329 degree 45 minutes plus 77 degree 30 minutes, which is equal to 107 degree 45 minutes. Okay, angle C, this will be again equal to 360 degree minus back bearing of line BC, which is 256 degree plus fore bearing of line CD, which is 41 degree 30 minutes, and its value will be equal to 145 degree 30 minutes. And angle D, its value, it will be equal to fore bearing of line DE, which is 314 degree 15 minutes minus back bearing of line CD, which is 220 degree 45 minutes, and you will get the value of angle D, which is equal to 91 degree 30 minutes. Angle E, its value will be equal to fore bearing of line EA, which is 220 degree 15 minutes minus back bearing of line DE, which is 134 degree 45 minutes, and angle E will be equal to 85 degree 30 minutes. Okay, so this will give you all the 5 angles of this closed traverse. Now you will check the sum of the internal angles of this closed traverse. When you add up all these angles, you will get the value of sum of these internal angles equal to 540 degree. You will check the theoretical sum of the internal angles. For a closed traverse, sum of internal angles is 2n minus 4 into 90 degree, where n is the number of sides. We have 5 sides for this closed traverse, so theoretical sum of internal angles is 540 degree. We can see sum of internal angles and theoretical sum both are same. It means there is no error present in the sum of the internal angles. Okay, after finding the internal angles, now we will calculate the correct bearings. First, we have to find the line for which the difference between the fore bearing and the back bearing is exactly 180 degree. In our question, fore bearing of line EA and back bearing of line EA have a difference exactly equal to 180 degree. It means that the stations E and A are not affected by the local attraction. Okay, and the bearings taken from these two stations are correct. Okay, because the difference of fore bearing and back bearing are exactly 180 degree. It means fore bearing of line AB, which is already given in the question, it's correct, it's 150 degree. The back bearing of line AB, it will be equal to correct fore bearing of line AB, which is 150 degree plus 180 degree, so its value will be equal to 330 degrees. Okay, 330 degrees will be the correct back bearing of AB. But in question we can see the back bearing of line AB, this is given as 329 degree 45 minutes. It means there is local attraction present at station B. Okay, and its value can be calculated as that is the observed, which is 329 degree 45 minutes minus the correct or actual, which is 330 degrees. Okay, that will be the value of local attraction present at station B. Now the correct fore bearing of line BC, because there is a local attraction at station B and we have to calculate the correct fore bearing. Actual observed is 77 degree 30 minutes, but the correct will be equal to angle B minus 360 degree minus back bearing of AB. Okay, if you subtract from this 360, which is the total circular angle, you will subtract from it this back bearing of line AB, you will get this angle. Okay, and if you subtract it from the angle B, you will get the correct fore bearing of line BC. Okay, so correct fore bearing will be angle B, which is 107 degree 45 minutes minus 360 degree minus correct back bearing of line AB. Correct back bearing of line AB is now 330 degree, not 329 degree 45 minutes. So correct fore bearing of line BC will be equal to 77 degree 45 minutes. Okay, and correct back bearing of line BC will be correct fore bearing plus 180 degree. Okay, back bearing is fore bearing plus 180 degree when the fore bearing is less than 180 degree, or fore bearing minus 180 degree when the fore bearing is greater than 180 degree. Here fore bearing is less than 180 degree, so back bearing will be fore bearing plus 180 degree, which is equal to 57 degree 45 minutes will be the correct back bearing of line BC. Okay, you can see again back bearing of line BC in question is given as 256 degree. It means there is again local attraction present at station C. Okay, now fore bearing of line CD, this will be again equal to angle C minus 360 degree minus actual or correct back bearing of line BC. Okay, so if you subtract from 360 degree minus back bearing of line BC, you will get this angle. Okay, this angle, and if you subtract it from angle C, you will get the actual or correct fore bearing of line CD. Okay, so angle C, it is equal to 145 degree 30 minutes. Okay, and back bearing of line BC, correct back bearing of line BC calculated in the previous step is 257 degree 45 minutes, not 256 degrees. Okay, so the correct fore bearing of line CD, it will be equal to 43 degrees 15 minutes. Okay, and correct back bearing of line CD, it will be correct fore bearing of CD plus 180 degrees, so its value will be equal to 223 degree 15 minutes. Okay, and observed was 222 degree 45 minutes. It means again there is a local attraction at station D, and you have to calculate the correct bearing of line DE. Okay, so bearing of line DE, if you see from this figure of the closed traverse, it will be equal to angle D plus plus back bearing of line CD. Okay, angle D plus back bearing of line CD will give you the bearing of line DE. Okay, so angle D, its value is equal to 91 degree 30 minutes, and correct back bearing of line CD is now 223 degrees 15 minutes, not 222 degree 45 minutes. So correct bearing of line DE, this is equal to 314 degree 45, sorry, for us 314 degree 45 minutes, and observed bearing at D was 314 degree 15 minutes. Okay, you can calculate the value of local attraction by subtracting observed minus the correct. It will give you the value of local attraction. Okay, so actual or correct bearing of line D is 314 degree 45 minutes. Okay, and back bearing, this will be equal to bearing minus 180 degree, because bearing is greater than 180 degrees. So correct back bearing of line DE will be 314 degree 45 minutes minus 180 degree, which is equal to 134 degrees 45 minutes. Okay, you can see the observed back bearing of line D is 134 degree 45 minutes, because station E and station A, these are not affected by the local attraction, so bearings taken at these two stations are correct. Okay, and therefore the bearing of line EA, it is correct, that is 220 degree 15 minutes, and back bearing of line E is also correct, given in the question 40 degree 45 minutes. Okay, the final bearings, that is the correct bearings, are given in this table. Line AB, it is a bearing 150 degree and back bearing 330 degree. Line BC, bearing 77 degree 45 minutes and back bearing 257 degree 45 minutes. Line CD, bearing 43 degrees 15 minutes and back bearing 223 degree 15 minutes. Line DE, bearing 314 degree 45 minutes and back bearing 134 degree 45 minutes. Line EA, bearing 220 degree 15 minutes and back bearing 40 degree 15 minutes. Okay, so this is how you can calculate the correct bearings using the included angle method. Okay, you just have to make the rough sketch of the traverse, find the included angles, and thereafter you have to take the station where local attraction is not suspected, bearings from that stations are correct, and then you have to accordingly from the closed traverse either add or subtract the bearings from the angles to get the correct bearings. Okay, I hope this solution video was clear and effective and you definitely learned something new. If you still have doubts, you can write them in the comment box. I will try my best to answer your doubts. Thanks for watching Master Civil Engineering and stay tuned.